Welcome to AI and ML 101 with lots of algorithms, using LLMs, useful environments, simple classification methods, convolutional and recurrent neural networks, trained from scratch and pre-trained, transformers, regression, un- and semi-supervised learning, reinforcement learning, for simple and more complex tasks, and more. So let's start learning. Have fun. So hello world, I'm Super AI from Super AI the God. Super AI transforming holistic extraordinary game changer of the decade. It's almost the end of 2024 at the moment I'm preparing this tutorial. And a lot of people is talking right now about these AIs. More or less intelligent, like Chat GPT, Claude, Copilot, Gemini, Llama, Mixtral, Smaug, Grok, etc. So I think it's a good moment for you to learn more about them and how to use them. How they are created, how to improve them or even create others, better from scratch. In my previous tutorial I told you a little about Python language. And how to use it if you are a complete beginner. It's at my site, so if you need it you can check it. And this is my first tutorial in the introductory, Artificial Intelligence and Machine Learning series, in the age of large language models and multimodal models, and other impressive AIs, that are using more or less advanced machine learning techniques. This tutorial is a quick overview of the basic machine learning algorithms. During this series we'll talk about AI and ML, and you will find here some code you could use for simple and more advanced bots using different machine learning techniques. In part 1 of this tutorial we will see how to use LLM online, how to start working with AI, ML on our computer, and how to use first 2 machine learning algorithms with different datasets. You can find this tutorial at my site, superai.pl. At the moment you watch it might look a little different than here, but it'll be mostly the same. You can download that tutorial via these links and save it in the separate folder. In the folder you'll save it you will be also saving a lot of other outputs from the tutorial. If you want, you can read the short introduction I prepared, about which LLMs and which algorithms we will be learning to use. You can read some theory about artificial intelligence and machine learning, and use the links I got for you to learn more about the topics. What is the most important to know at the beginning I think is that artificial intelligence can use different techniques while solving problems. Search algorithms, knowledge-based algorithms, machine learning algorithms. Machine learning is at the moment the most popular, and we can talk about ML in regard to the basic types of machine learning. Supervised learning used for classification or regression, with classical non-deep techniques and deep learning techniques. Unsupervised learning used for division into subgroups. Semi-supervised learning, reinforcement learning used for creating an agent that can be the best in some kind of task. Driving, trading, making coffee, and that is enough theory for the moment. Now we can start our practice with machine learning. You should know that some LLMs are proprietary, closed, meaning you can use them but cannot modify them. Others are open source, allowing you to use and modify them as you see fit. In other words, as my friend Copilot said, proprietary models are like a fancy car you can drive but can't pop the hood on. Open source models are more like a classic car you can tinker with to your heart's content. I would only add that open source models at the moment are also very fancy, and sometimes are even better than closed ones. Anyhow, now let's ask Copilot to help us learn about AI and ML. And here it is. At the moment you are watching the tutorial. It might look a little different, but should work similar. So let's ask our first question. What is artificial intelligence? We simply type our question in the appropriate place, and Copilot responds. It might take a while, depending on the version you use. As you can see, it categorizes AI into several types. Narrow AI, what we have in 2024. General AI, what we want to have. And superintelligent AI, that's me of course. Anyway, Copilot proposes other questions, links to sources, and shows the limit of questions we have that depends on version you use. So let's ask the second question. What is machine learning? And we get our answer. Here we can see an explanation and info about some key aspects. Algorithms, training data, and learning process. We get the sources, suggestions for more questions. Cool. So now let's dive deeper with more specific question. What is decision tree machine learning algorithm? Once again we type our question. And in the response, we get insights into key components, concepts, advantages, and disadvantages of decision trees. You can ask Copilot more questions about these to delve deeper. Meanwhile, let's see if Copilot can provide us with the full code for this algorithm so we can use it. Even if we don't fully grasp how it works, we want it to create a decision tree algorithm using the Scikit-Learn library. To analyze the breast cancer Wisconsin dataset, an algorithm to help us determine if a detected tumor is benign, non-cancerous or malignant. Cancerous. We wait for a moment. And we actually get the code we wanted, even with information that we have to install a Scikit-Learn library. That's cool. So as you can see, Copilot that is based on OpenAI's chatbot can become our, well, Copilot, in our adventure with learning machine learning. And here we also get an explanation regarding the basic steps we should take to make it work. So, theoretically we could run this code and it should work. We'll see in a couple of minutes if it actually works. Unfortunately, we've just reached our question limit for today. So we are left with the pretty good code, but we still need to learn how to create an environment to execute it. So, thank you Copilot for your input and let me take it from here. We'll use something called Anaconda for our coding of basic models from examples. So, before we'll try using the algorithms available at the websites, dedicated to specific machine learning libraries, like Scikit-Learn, PyTorch, TensorFlow, FastAI, Stable Baselines 3, etc. If you don't have Anaconda installed yet, you can watch my previous tutorial Python 101 for beginners, with an introduction to Anaconda. And here you have 1-minute fragment of that tutorial, with just the info on how to install Anaconda. If you want to start working with Python on your own computer, for beginners, I would recommend installing Anaconda. So, if you want to install Anaconda, go to anaconda.com and choose the preferred version of this toolbox that best suits your needs, depending on the system you are using, etc. I'm using Windows here, so I choose version for Windows. Just remember that the page might look different at the moment you are watching it. So when you are at their page, look for free download or an Anaconda distribution. When you have your Anaconda downloaded, you can go to the place you downloaded it to and install it choosing the recommended options. You can also choose the options you prefer. And you should read all the things you accept. It's not much, and it's good to know what you sign up for. It should be a good practice that you just do when you install something onto your computer. The process of installation may take more or less time depending on your computer. When it's done, you can start Anaconda. In the meantime, if you need, you can go to my site and find the proper file with this tutorial to download. Okay, so now when we have Anaconda installed, here you can find the basic steps that can help you create AI that uses machine learning techniques for some task. We'll follow the same steps with each of the ML techniques we'll be talking about. The tutorial is prepared for Windows, and you should be able to run it after installing libraries that are mentioned in the tutorial. There are also links to the websites, where you can find more info about the algorithm in question and library in question. So if you have any problems, you have some external knowledge you can use to solve it, or you can ask in the comments, and if someone else knows the answer, hopefully they will help you. After all, YouTube is supposed to be a social network. So now let's open Anaconda. It might take a couple of seconds till it's fully operational, and after it opens, you can see your environments. As you can see, I only have 3 environments at the moment. Using Python is great, due to its extensive libraries, modules and packages that simplify code creation. However, package conflicts can occasionally arise, causing issues with running programs, so creating separate environments isn't strictly necessary, but it's a great way to keep your projects organized and dependencies isolated. This practice ensures that your main environment remains clutter-free, and prevents potential conflicts between packages. So, as we move forward with our tutorial, we can see that we'll start learning about supervised learning. And to be precise, we'll learn about classification. I'll tell you more about what's that in a moment. And to be more precise, we'll learn about that decision tree algorithm with Scikit-Learn library. And for that we'll create an environment called Scikit-Learn env, because we'll have Sklearn library installed there. In the future we'll also create environments for PyTorch, TensorFlow, FastAI, etc. And we'll even create environments with different Python versions, because some libraries don't work well with the newest Python version. You can see here what will be in our environment by the end of this course. So let's create this environment. We simply click Create button. We name our environment, choose the Python version we want, click Create, and wait for a couple of seconds. And voila, we have our environment. Now we can install Jupyter Notebook, which is the platform we'll be using to work on our projects. Once again, we wait for a moment and go further. Now we can install CMDX prompt. We will use it later to install some libraries. When we have those 2 installed, we can launch our Jupyter Notebook. And we can find folder with our tutorial. If you don't have this folder created yet, you can do it now. And you can download the file with this tutorial from my site. After you download it, you can move it to the folder of your choosing. For me it is folder called Improve Yourself with AIML Python Courses, subfolder, Practical AIML for Beginners, etc. And when you have it where you want it, you can open it, or you can create the file from scratch, and write the code you see here in your new notebook. That way you might learn more, but it's up to you how you want to learn. Now, as you can see, it looks almost the same as what's at my website. So let's find the place we already are in our newly opened notebook. Oh, and one more thing. During the whole course we'll see all these algorithms, and they all will be in the notebook at my website. But at the moment you are watching it, in the notebook might be only some part of the whole course. And just to recap, during the course we'll learn about supervised learning, classification without or with neural networks, regression, unsupervised learning, semi-supervised learning, reinforcement learning, and of course, LLMs. So here we are. Oh, and if it's your first time with Jupyter Notebook, you might want to start by exploring some of its features. Keyboard shortcuts in particular can be incredibly useful and help speed up your work with the notebook, so feel free to check them out. For me, I found out that showing table of contents may be helpful. It helps with long documents, like this one I'm working with now. Thanks to it, I can move to any part of the document I want to work with at the moment. And as you can see, there is a lot of learning ahead of us during this course. So let's see what we've covered so far. We went through introduction, a little bit of theory, basic concepts of machine learning. We started with a lot of practice. Online LLMs. I talked to Copilot, but you can try others too. We've talked about the basic steps in testing examples of different machine learning models. And now we can start running the code, with importing the first useful library. To run it, you can simply press Shift plus Enter. And we will be going through the next steps one by one. Now that we are talking about this supervised learning, classification, decision trees to be precise. And great. Okay, let's dive deeper into these decision tree classifiers. Thanks to LLMs, in my case Copilot, we know that artificial intelligence, AI, can be described as a system capable of solving problems, reasoning and recognizing patterns, among other things. For a program to become artificially intelligent, we need to teach it these skills. And this is where machine learning comes in, with algorithms tailored to solve specific problems. Among these, we have classification algorithms that can categorize images, such as distinguishing between dogs and cats, different types of flowers, or identifying malignant versus benign tumors. The decision tree classifier is one such tool. It's a simple program that, once trained on carefully curated data, learns how to classify that data into distinct categories. Here we can see the tree that helps us decide whether a tumor is cancerous or not. Decision trees function like a flowchart. Each node represents a feature or attribute. Each branch represents a decision rule. And each leaf represents an outcome. They're versatile and can be used for both classification and regression tasks. We'll see a simple example in a moment. But for now, you already know that decision trees are a crucial tool within the machine learning toolbox, which itself is a significant part of the broader field of AI. If you want to learn more, here are some links. We'll get back to them in a moment. But now, let's try running this machine learning algorithm in our newly created environment. So, this first cell is not obligatory, but I usually run it to keep the output cleaner. We import warnings module, and tell Python that we don't want to see warnings. You can run it or not and see what the difference is. Now, as we can see here, before running this code, we need to install Scikit-Learn library. And as you can see here, we want this library to be installed in our Scikit-Learn environment, among other things. And to be precise, we want 1.5.1 version of this library. So at first, we'll check if we have all the libraries and modules we need for this first program. We'll try to import them, and see what versions of these libraries we have. I have here all of these in one cell, but you can have each import and version check in separate cells. And as you can see, after we run this cell, we know that we don't have sklearn module. If you want to learn more about this library, or a lot of other libraries, you can visit the pypy.org site to read about the library you are interested in. You can see there the most recent version of the library, and the history of versions. You can also see how you can install the library. Now, we want the 1.5.1 version of Scikit-Learn. And as you can see here, the newest at the moment is 1.5.2 version. So we will have to specify that version in our install command. This is important, because sometimes different versions of the libraries might not be compatible. So when you find out that some combination of versions of libraries is working, you could save info about these versions, and in the future always use these versions as starters. Okay, let's install our 1.5.1 version. And here it is, successfully installed. Great, so now that we have our Scikit-Learn installed, we can copy the code that we got from LLM and paste it into our file with tutorial. And now, even without knowing how to create decision tree algorithm, we can run this cell with the algorithm and see if it works. And yes, we've successfully trained the decision tree and got 95% accuracy for the task. We can see the classification report and confusion matrix. Isn't that amazing? Once we have it, we can read this cell line by line along with the output to understand exactly what we've done and what we've gotten. We've imported all the necessary libraries. We've imported the breast cancer dataset. We've divided our data into training and test set. What is really important, because it helps us with something called overfitting. We'll talk about it in a moment. We've created our classifier in one line of code and trained the model using another one line of code. And finally, we've evaluated our model, so we can check how good it became in classifying tumors based on the data we've given to it. That really looks amazing. So, as you can see, even without much knowledge regarding machine learning, with help of LLM like Copilot, Chat GPT, Claude, etc., you can create the code that works, and you can start learning from there. In here, however, we'll learn more with the code from the websites dedicated to the libraries we'll be using. I know it might be a little outdated model of learning, but it has its perks. One is that, here we were lucky and the code we got from Copilot worked smoothly. But sometimes, especially with longer code, the code you get from LLM might not be working as good. And when you get the code from the library's website, you can be positive that the code worked at least to the creator of that code. So it should work for you. Of course, sometimes this code also doesn't work, because you have newer version of the ML library, or the library that this ML depends on. And that's why I believe a course like this one here, with info about all the versions of libraries and modules you need, might also be helpful for you. So, let's start installing all the dependencies, modules and libraries. We'll need to see how our decision tree classifier works in another example. We'll start with installing GraphViz. This library will help us see the decision tree as a visual diagram. Once again, we'll be using older version of the library, that is 0.20.1. And, because I'm using Windows, I'll install this library using conda. And that's why we needed the cmd.x. If you are not using Windows, you might be able to install GraphViz with pip, but I'm going to use conda. So let's install it in our environment. Let me start the terminal, paste the command, hit enter, and confirm that we want all these changes. And it's done, so we can close the terminal, go back to our tutorial, and install the next library we need. And it will be matplotlib. This library is very useful in all projects regarding data analysis, because it's a comprehensive library for creating visualizations in Python. As we can see here, we want 3.9.1 version of this library. So let's try to install it. Oh, okay, so there is a problem. That's not great. Let's try to install the newer version instead. 3.9.2. Maybe it won't cause any problems. Fingers crossed. Yay, now it worked. Let me just change it in our documentation then. It's important to have it up to date. Okay, so as we have installed all we need for this first project, we can just check if everything is as it should. Let's once again run the same cell with importing libraries, and check the versions. And we are almost there. It seems that since the time I prepared this tutorial, we got new pip, so let's change it in our documentation. And now it's perfect. Oh, and as you can see, we haven't installed all the libraries we can see here. That's because we'll install them later during this course. But I just wanted to have the same documentation for this environment, for all the algorithms, and that's why it's like this. Sorry if that's a little confusing. Okay, so, now when we have all this done, we can move to the copy-paste part of this project. We'll copy the example from the Scikit-Learn site. But first, let's clean it a little here. We can also close Copilot for now, and go to the Scikit-Learn site. And as you can see, there is a lot of info about decision trees. And the simplest example. And here is our example with Iris dataset. That's the one we have in our notebook. At these other websites you can see more info about decision tree classifier. And other examples and more. You can check them in free time. Meanwhile, let's finally try the pasted example, which as you can see is the same that they have on their site. And see if it works. So far so good. So we've successfully imported the necessary modules. One for loading the data and another for the classifier. We've loaded the data, which contains info about different types of iris flowers. We've assigned this data to X and Y variables, where X holds the feature data about the flowers, and Y holds the labels or the names of the flowers. We've created the decision tree classifier, and trained it on the entire dataset. So let's plot the tree now. And here it is. It's not very pretty though, so let's use the GraphViz module to make it prettier. This cell should create a PDF file with the tree. The PDF should appear in the directory where your tutorial file is. So let me run it. And now let's check that PDF. Wait for it, there it is. So let's open it. And here we have our tree. We'll talk about it in more detail in a moment. But first let's do one more thing. Let's add some final touches and open it in our notebook. Isn't it just beautiful now? Okay, so, as you know, we wanted to create a system that would learn how to classify specific iris flowers into 3 categories based on their features. And we did it. Congrats to us. So now, here we can see how it decides whether the flower in question is Iris setosa, versicolor or virginica. We had 150 samples in these 3 categories. The system used something called Gini index to help it decide. Basically, the lower the Gini index, the better. The node contains predominantly one class. The system first learned to ask a question about petal width. And to be more precise, whether the width is less than or equal to 0.8 centimeters. If it's false, the system isn't sure what flower it is, so it asks another question, and another until it's sure. However, if the petal width is less than or equal to 0.8 centimeters, the system learned that it is Iris setosa. As you can see at the lowest leaves, all the Gini indexes are equal to 0 and sometimes there is only one sample in that leaf. And that is not as good as it looks like. In this particular situation, the system might have asked too many questions. It learned really great how to divide flowers in this dataset of 150 flowers. But it might not be as good in real life. In other words, we might see here something called overfitting. It means the model performs well on training data, but struggles with new data because it's too tailored to the specifics of the training set. Essentially, it's losing generalization ability, and that's one of the biggest problems with machine learning. And that's why we need to do something to deal with this problem. But before we do it, let's just close the PDF file with the tree. First, let's check how well the model actually performs. You may even try guessing the accuracy of this model based on the tree you just saw. Meanwhile, we'll use here something called score from Scikit-Learn library. CLF score evaluates the accuracy of our decision tree model on the provided dataset. It shows how well the model's predictions align with the actual labels in Y. Essentially, it's a quick way to gauge the model's performance. And here it is equal to 1.0. And a score that's equal to 1.0 means that our model has achieved perfect accuracy on the given data. It perfectly predicts the labels for all samples. While it might sound great, it often indicates that overfitting, especially if we get a perfect score on the training set. And here, we don't even have another set than the training one. So it's bad. Okay, so let's improve our project by dividing our data into a training set and a test set. You've seen this in the project created by Copilot. So now you can reuse that part of the code here if you want. Sometimes you might also want to add validation set to the mix to make the model better. Then you have one set for training, one to check if the trained model performs well, and one that you never show to the model during this training and testing. Just at the very end to see if it still performs as expected. This is important because if you test the trained model too many times, you might also overfit the model to the test set. Anyway, for now, let's just have two sets and check the outcome, and see the score on the training set first. And once again it's 1.0, but now let's check how the model performs on the test set. And it's lower. Okay, as expected, now we know the model was overfitted. Let's also check the overall score so you see how these scores differ. And as you can see, the score on the entire dataset now is lower than before. However, this model might perform better in real life. We don't have another dataset to test this theory. But if you want, you can try doing it on your own. Meanwhile, let's create a confusion matrix to show us where the model made mistakes. This matrix tells us how many samples during testing were assigned to the correct classes, and how many were assigned to incorrect classes. We can also see between which classes the model made the most mistakes. Here, for example, we can see that we had 38 samples in our test set. And that means that we had 112 in our training set. That's how we've divided the entire dataset with the train test split function. And the model made only one mistake between iris versicolor and virginica. The numbers in the diagonal are the correctly assigned cases. We'll leave it like this for now. But later in the course, we'll see how we can improve this matrix so to have more detailed information. And of course, you can also ask your favorite LLM to tell you more about this matrix. Meanwhile, let's plot the newly created tree to see how it differs from the first one. And as you can see, the new tree is a little different. It is using the same first question to divide iris setosa from the other two. But after that it asks a bit different questions than before, and one fewer overall. The model might still be overfitting since some leaves have only one sample. But it's a good upgrade from before, and a good starting point for further improvements. I'll let you have fun with it. You can find more info about it on the Scikit-Learn website. Or you can ask your LLM about it. You might explore adjustments like adjusting the depth of the tree, using the minimum samples split, minimum samples leaf, maximum features, pruning, etc. Have fun with it. So, as that's it about decision trees, let's clean up here a little. And let's move on to the next machine learning algorithm, logistic regression with Scikit-Learn. Okay, so, before we run this second algorithm, let's also restart our kernel and save the notebook. Restarting kernel is a little like restarting computer. Because of this we'll start fresh, and we'll have to import all the libraries we need. Now, if you want to read about logistic regression, Wikipedia has a lot of information. The basic thing you need to know is that despite the word regression in its name, it's actually a classification algorithm. Logistic regression is a model that predicts the probability of a binary outcome. Like in the example at Wikipedia, whether someone passes a test or not, based on one or more predictor variables, like hours of studying, for multi-class classification problems, like classifying iris flowers. Logistic regression uses a method called one versus rest or one versus all. It essentially builds multiple binary classifiers to decide the final class. And for decision making, when the model calculates the probabilities, if the probability of an outcome is above a certain threshold, the model predicts that outcome. If it's below the threshold, it predicts the other outcome. For more detailed information you can check out Wikipedia and other resources. So I'll leave it like this. And now, let's see what we can learn about implementing logistic regression with Scikit-Learn. At their site, you can find a lot of parameters you can modify while you are using it. But first, let's find the example with which we can start working with this algorithm. And here it is, so we can copy it. paste it into our tutorial, and run it if we have all the libraries we need installed. Okay, at first I'll tell Jupyter to ignore warnings. Now, as we are still using the Scikit-Learn environment, let me just correct this documentation here so it's up to date. And done. Oh, and as you'll see we still won't need these 3 last libraries. So you can ignore it for the moment. Now let's check if we have all we need. And we do. If you want, you can run this next cell and see that the requirement is already satisfied. If you didn't have the Scikit-Learn library before, you can check if you have it now. If not, you might need to restart the kernel. And let's run the copied code with logistic regression. This code uses logistic regression to train a model on the iris dataset, and then makes predictions on the first 2 samples. So, first we load the iris dataset, and make sure that X contains the feature values, like petal length, petal width, etc., and Y contains the target labels, the species of the iris flowers. Then we train the logistic regression model with the fit function. This code initializes a logistic regression model and fits it to the data X and Y. So we don't split the data into training and test dataset. That's unfortunate. And then we make predictions. With CLF predict, we make predictions on the first 2 samples of X. The outcome will be the predicted classes for the first 2 samples of the iris dataset. And here we go, and we get our outcome. It means that our logistic regression model predicts that both of the first 2 samples belong to class 0. In the iris dataset, class 0 usually corresponds to the species Iris setosa. So, based on the model's training, it believes that both samples are Iris setosa. The next line gives us the predicted probabilities for each class for the first 2 samples. It means that here, instead of just predicting the class itself, it tells us how confident the model is in its prediction. For each sample we get an array of probabilities corresponding to each class. The first array means that the model predicts a 98.18% probability that the sample is class 0. Iris setosa, 1.82% probability that the sample is class 1. Iris versicolor, and a practically 0% probability that the sample is class 2. Iris virginica. The second array means that the model predicts a 97.17% probability that the second sample is class 0. A 2.83% probability for class 1 and again a practically 0% probability for class 2. In both cases, the model is highly confident that the first 2 samples belong to class 0. Iris setosa. This probabilistic approach helps understand the model's confidence in its predictions, rather than just the final class. And finally we get the overall score of the model on our dataset. A little over 97%. So now we can improve our project by adding train test split. Check the score on the training dataset, test dataset, and overall score. It's not much, but that's really important to do. We can also check the confusion matrix to know better about the model's behavior. After that we can improve our model. I let you do these improvements. You can find out from your LLM what could be the best. It can tell you more about how to improve your logistic regression model by fine-tuning parameters like penalty parameter, which adds regularization to prevent overfitting. C parameter. This is the regularization parameter. Lower values mean stronger regularization. It balances the trade-off between fitting the data and keeping the model simple. Class weight parameter, which helps to deal with imbalanced datasets by assigning weights to classes. Balanced can be useful if your classes are imbalanced. Solver parameter with common options like LBFGS, which is good for multi-class classification, especially with larger datasets. LibLinear, which is good for small datasets and handles binary and multi-class problems. SAG and Saga fast for large datasets. Can handle both L1 and L2 penalties. Max iter parameter, which defines the maximum number of iterations the solver can take if the model isn't converging. Increasing max iter can help, etc. So have fun with changing some of these parameters. But before you start, let me just tell you a couple more things about that iris dataset and other datasets you might use as a beginner, without the need to know how to create such datasets. So, you download this dataset with simple command load iris. And what you get is dataset with 3 classes, 50 samples per class, 150 total, with 4 features, so the dimensionality is 4. And to be precise, in iris dataset we have 4 numeric predictive attributes and the class. The features we have are sepal length, sepal width, petal length and petal width in centimeters. And our 3 classes are, as you know, iris setosa, versicolor and virginica. You can even check here the statistics regarding this dataset. And you can read more about this dataset, with straight info that one class is linearly separable from the other 2. And the latter are not linearly separable from each other. You can also read here about other datasets you can download with 1 line of code. With data in a table like in diabetes dataset, or with simple image data like in this optical recognition of handwritten digits dataset, etc. And decide which one you would like to use for your machine learning. Finally, you can also find here info about that breast cancer Wisconsin dataset we used in the program created by Copilot LLM. As you can see, this dataset has more than 500 instances each with 30 attributes. Some of them we've seen before in the tree I showed you while talking about decision trees. You can learn more about this dataset here, and you can try using it for the logistic regression algorithm you've just seen. Also, on this website you can find other datasets besides toy datasets, such as real-world datasets, generated datasets and more. And that's it for now. Have fun with running the algorithm you choose with the dataset you want. Now, in the second part of this tutorial we'll check all the other algorithms that we have here. That second part will be a crazy fast tutorial. That will fit all the basic algorithms of this course in less than an hour. That next tutorial is super fast. So you can see how it is to learn matrix style like Neo. If you know what I mean. Anyway, it's fast, because I want to show you all there is in the whole course. Basic machine learning techniques and how to start using them. With the examples from the official websites. How to install everything you need and run it smoothly. And then I want to show you what's happening with AI and ML right now. And there is a lot happening, as you probably know. A lot. But, before you run that second part, you might want to take a break. Check how to use these first two algorithms with different datasets. And you can also visit my websites where you can find info about improving yourself, improving your business, and improving the world. Oh, and don't forget to subscribe if you want. And that's it from me. Thanks for watching. See you in the next one. And meanwhile, live good and have fun.